Good morning, Chemistry in the Community students. Here we are on Chemistry in the Community's Google page. I have block 2B, but if you're block 4B, it'll look very similar. So what we're doing today is our first Gizmo. Those of you who have done Gizmos together, please suppress your groans. Those of you who haven't, here's what we're doing. Now we all have a unique username and password, which you can find on the stream part of our classroom by scrolling down. Here it is, posted on September 17th. I am sharing a list of usernames and passwords for our explorerlearning.com website. So you click on that to open it, and everybody can see everybody else's usernames and passwords, and that's because it's not that big a deal. You can only do somebody a favor by logging in as them. So what you're going to do now, you have the username and password, open a new tab, and type into the search bar, explorelearning.com. It opens up a page that looks like this. Now in the upper corner, I'm going to log out. In the upper corner of this, you have this login/enroll, so you can log in here, or you can log in here. So just copy and paste your username from this sheet. They're all computer generated into username. You can see I've tried logging in as a few different students. And then type in your password. I'm going to type in mine. Okay. So now you'll be in here and you should be able to see, you may have more than one teacher doing Gizmos. So make sure you're clicking on me. I'm Mrs. Hyatt, Chemistry in the Community. So you can see we have a Gizmo here that we're going to work through. So to find the Gizmo sheet that we're going to work through, please go back to the Chemistry in the Community page. You are on Stream, click over to Classwork. Now whether you are 2B or 4B, it will be in the same spot. So I want you to scroll down to today's date, which is Thursday, 9/24. And you have two things here. You have this and you have this. I want you to open the one that has the clipboard by it and says Density via Comparison Gizmo. And if you click to open that, you get this beautiful page, which, no, I forgot to delete some of the answers. You can put your name at the top. You don't have to. Now we go over to Explore Learning and we're going to launch our Gizmo. So click on the name of the Gizmo. And if you hover over it with your mouse, you'll see a little rocket that says Launch Gizmo. Beautiful. Now we'll work through it together. And if we look, the prior knowledge questions I didn't delete, but that's okay. Why do you think the man is floating so high in the water? Salt water is more dense than regular water, is what the class came up with, and that's correct. And if he tried to do this in a normal pool, he would absolutely sink. So now the warm-up says, whether an object floats or sinks depends on the density of the object and the density of the fluid. The first thing says, put object A into beaker 2. So you take object A and you drag it over to beaker 2, and look at it go. It sinks. So if we look at that, we put that in there, it sinks. What happens? It sinks. Is object A more or less dense than water? Beaker B was full of water. Or beaker 2, I mean, was full of water. We know that object A is more dense than water because it sinks. And if something sinks, that means it's heavier or more dense. Now drop object B into beaker 2. And if we do that, I forgot to erase the answer, but you can see it floats. Yay. So we put that, it floats. It's less dense than water. So here we go. It says drag object A into beaker 1. So we did this. It sinks in 1.5 and it floats in 2.5. That means the density is between 1.5 and 2.5. Okay, so I'm just following the directions. And we're doing that with all of the other objects. We're dragging them into every beaker and recording whether they sink or float. Okay, so you're just dragging objects from beaker to beaker to beaker. Okay, I 100% trust that you can do this better than what I'm doing. I'm just sort of randomly dragging them around. Sorry, guys. So that's what you're doing. You're following this, an estimated density. I'll show you. We walked through this together. So if you're doing this on your own, you might want to pause it right now while you work. And then take a look and compare your answers with ours that we did in class. Here is the chart, the estimated density. This is how we get this. Take a look at sinks and floats. And between where it says sinks and floats for the first time, that's where our density is. So for object C, it sank in 1 gram per milliliter, but floated in 1.5. So for object C, we picked a number between 1 and 1.5. We picked 1.2. Same thing here. Well, object E, it sank in the first beaker and floated in the second. So it sinks in 0.5, it floats in 1. Pick a number between 0.5 and 1, and that's what we did here. These are just estimates. Object F floated in every single beaker, which means its density has to be less than 0.5, and that's why we picked 0.2. So for number 3, we dragged objects B and E into beaker number 2, which is denser, E. They both floated, but object E was a little bit lower in the beaker than object B. And if you want to see that for yourself, here we go. Object E and object B. See how E is a little bit lower in the beaker? That's how we came up with the idea that it was a little bit more dense. And if we do this, object A and B, object A is denser. They both sink, but object A, if you do this, sinks much faster. So if we look at that, object A, watch it go down, object B. So you can see how A goes straight to the bottom and B kind of took its time. So that's how we knew that A was a bit more dense. And object A and B are placed in beaker 4. If we do that, we can see they both float in beaker 4. I'll move C out of the way. But A floats much lower in the beaker than B. So A is more dense. So that was our relative density gizmo. If you missed any of these answers or yours are different, then you'll probably want to backtrack and figure out what you got wrong. Let me know if you have any questions. Thank you.